The diagram shows a square ABCD where each side has length 12 centimeters. So if each side has a length of 12 centimeters, it means BC is also 12 centimeters and DC is also 12 centimeters, right? Then points E and F lie on the sides BC and CD respectively and are such that BE is a third of BC. If BE is a third of BC, it means BE is 1/3 times 12, because we know BC is 12, so it means BE is 4, right? BE is 4. And DF is also a third of DC, meaning it's also 4, right? BE and DF are equal. The arc EF is part of a circle. The arc EF is part of a circle with center A. EF is part of a circle with center A, right? Meaning this is a radius and this is also a radius, right? And they are both equal. The shaded region is bounded by the arc EF and the line segments EC and FC. Then part A says, show that the size of angle EAF, E to A then to F, it's this angle right here, right, is 0.9273 radians, correct to 4 significant figures, right? And for that we are going to try and get this angle right here. Then we multiply it by 2 because it's also equal to this one. Then we subtract that value from 90 because we know this whole angle is 90. So it will be 90 minus this angle plus this angle, right? So in working that out, we'll say for this angle right here, let's call it X. We can see that we have the opposite and the adjacent, so we can use tan, and it's a right angled triangle, right? So we can say tan X is equal to 4, which is the opposite, and 12, the adjacent, and our X will be the tan inverse of 4/12, right? And punching this in our calculators, we get X equals 0.32175, right? And we're going to multiply this value by 2 so that we get the value of this angle and this one right here combined, right? And in doing that, we get that value as 0.643511, right? So finally, for us to get the angle EAF, which is this angle, we're going to say 90, which is half pi, minus the value we just got. So it will be half pi minus 0.643511, and this gives us 0.9273, correct as 4 significant figures, right? And for part B, it says find the perimeter of the shaded region. In other words, find the distance right around the shaded region, which is FC, CE, and arc EF, right? Let me use a different color. FC, CE, and arc EF, right? Those are the sides that we're going to be calculating. And so we'll say for perimeter, it is equals to FC plus CE plus arc EF, right? And FC is 8. Since DC is 12, 12 minus this 4 is 8, so FC is 8. And CE is also 8 because we're saying 12 minus this 4, so we get 8. CE is also 8. And now we're left with the arc EF to calculate. And for us to calculate arc length, we use r theta, right? But we don't have the value of r, right? So we're going to try and calculate it. We can see that this is a small right angled triangle, which we can use the Pythagoras theorem to get r, right? R will be the hypotenuse. So if we can say r squared is equals to 12 squared plus 4 squared, we'll get our r to be root of, that will be 144 plus 16, root of 160, right? That's our r, right? And the theta value that we calculated in part A. So for r theta, we'll say perimeter is 8 plus 8 plus r theta, which is root 60, plus theta 0.9273, right? And we get our perimeter as 27.73 centimeters, right? That's the perimeter for the shaded region. Moving on to part C, says find the area of the shaded region. Find the area of the shaded region. So for us to get the area of the shaded region, it's quite simple. We're going to first say area of the whole shape, right? Then you subtract area of the unshaded part, which is this part, to get area of the shaded part, right? So doing that, we will say area of the shaded region equals area of whole shape minus the area of unshaded region. Right? So area of the whole shape, that's 12 by 12, right? And this gives us 144 square centimeters. That's the area for the whole shape. And area of unshaded region, we have these two triangles, which you can call A and B, which have pretty much the same area, and this sector, right? So we're going to first calculate area of one of these triangles, then we multiply it by 2, then we add to the area of this sector, right, to get the area of the unshaded part. So area of a triangle, that's base times height over 2. So the base will be 12, the height will be 4 over 2, right? And that should give us 24. And multiplying it by 2, we get 48 cubic centimeters. Sorry, square centimeters, because it's area for the area of one of the two unshaded triangles. And for us to get the area of the sector, we're going to use half r squared theta. So it will be half. Remember, our r is root 60, root 160 squared. Then our theta is 0.9273. 0.9273. And punching this in, we get 74.184 square centimeters, right? So we're going to add these two values to get the total of the area of the unshaded part. So it will be 74.184 plus 48. Right, we get 122.184. Right, then you go back to our method where we said area of worship minus area of unshaded. So it will be this 144 minus the 122.184 to give us the area of the shaded region as 21.816 square centimeters, right?